Hello, sixth graders. Welcome to a very simple, very basic introduction to algebra. This presentation is designed to give you some review, but also just to point out what algebra is and why we study it. So, as a historian, of course, I decided to do a little research. The word algebra comes to us from the Arabic al-jabar, reunion of broken parts, and it is attributed to Muhammad al-Khwarizmi in the Al-Kitab. There's the short title of his book, and this is during the Islamic Golden Age. There were ancient Babylonians doing this, and a Greek, I believe, named Diophantus, and many others, but Muhammad al-Khwarizmi is credited for the word algebra, and the definition reunion of broken parts makes perfect sense because you are solving for a variable to balance the equation. Okay, I believe algebra comes from a word jabara, meaning like to set bones together or putting things together. So you're trying to reunite something and make things equal. You're solving for x, and you want both sides of the equation to be equal. So this is going to be a very abstract presentation on algebra. I don't have the experience with the scales that I probably should, the physical ones to teach it. But I'm going to go ahead and start with a simple problem, and we're going to talk about how to balance that equation. So here we go. Let's say I have 3x plus 2 equals 11. Okay, so 3x here, when you see 3 next to x, you have to think 3 times x. And oftentimes in math, you guys really can't see that very well. There's the multiplication symbol, but now that I've got an x here, I can use a different symbol, which is just a dot. This is a more advanced symbol for multiplication. So 3 times x plus 2 equals 11. That's all this means. 3 next to x just means you're multiplying it. If it had been x over 3, that would mean you're dividing. So 3 times x plus 2 equals 11. How am I going to reunite x with what it is? Well, first we have to get x isolated. We want to socially isolate x here, so let's go ahead and do that. I'm going to subtract 2 from both sides, and this cancels out that. I get 9 here. 9 equals 3 times x. Okay. Well, I have 3 times x equals 9. What I need to do is divide, because that's the opposite of multiplication, by 3. That cancels that out, and x equals 9 divided by 3, which is 3. Hopefully you can see that. Pull that down so you guys can see that. X equals 3. Don't take my word for it, though. Let's just go double check. So let's do 3 times 3, order of operations, plus 2 equals 11. Okay, 3 times 3 is in fact 9, plus 2 does in fact equal 11. So yes, x does equal 3. So we balanced the equation. We got x socially isolated, and we found out that x equals 3. All right, so let's do a different one here. Let's do x over 5 plus 5 equals 30. Okay, this one looks a little scarier because it's got this fraction here, x over 5. Sorry, my 5 looks like an S. That's terrible. They both look like S's. Let's do a better job, Mr. Adam. All right, so much better. X divided by 5 plus 5 equals 30. Well, order of operations means that we're not going to do anything. We're not going to add x plus 5 and then divide by 5. We're not going to do any of that. What we're going to do here first is we're going to do the easy part first, which is subtract 5 from both sides. 25 equals x divided by 5. Okay, so 25 equals x divided by 5. Well, what do I have to do here? I have to multiply x for 5. I have to do something here to get something, the x, to equal a number that divided by 5 equals 25. What do I do? Well, let's go ahead and multiply by 5 here, okay? 5 over 1, okay? And 25 times 5 is 125 equals 5x over 5, okay? Cancels out. X equals 125. How'd you do that, Mr. Adam? Well, what I did was I socially isolated x, and then I reunited x to what it was originally, 125. Let's erase this and go check our work. So I'm saying that x is 125. So if I put 125 in for x and I divide by 5 and I add 5, I should get 30. Okay? Well, order of operation tells us we have to do this first because this is division. This is an improper fraction. 125 divided by 5 is 25. Plus 5 does in fact equal 30. So there you have it. That one is also correct. So the correct answer for x is x equals 125. So the reason that we practice algebra is because it gets more complicated as you go along and you want to have a solid foundation. So I didn't start learning this until I was an 8th or 9th grader, and we're teaching this to 6th graders. So let's do another one. This time, x minus 4 equals 16. All right, x minus 4 equals 16. We have to isolate x. We have a minus 4 here. So in order to get rid of that 4, we're going to add 4, but we have to do the same thing on this side. We have to balance it. Add 4. 16 plus 4 is 20. Bring down the x. X equals 20. Well, let's go double check. Is x minus 4 equals 16? If x is 20 minus 4, that does in fact equal 16. So there you have it. A simpler example, but oftentimes I'll do a plus, but here you have a minus. If you're subtracting something from one side and you have to add it to eliminate it, you have to add it to the other side as well. Okay, so let's do another one. Okay, I'm just going to do completely random numbers here. 11x minus 9 equals 23. This one I did not just have in mind, I just decided to put this together. We'll see what happens. This is not going to be pretty, okay? This one's probably going to give me some sort of improper fraction or something, but it doesn't matter because I'm just going to do the exact same steps I did before. I'm going to get x alone, I'm going to socially isolate it, and I'm going to reunite it with the number that it actually is supposed to be to make the equation equal. So let's do what I need to do. I'm going to add 9 to both sides. Okay. 12, 32. Those cancel out. 11x equals 32. Now, in order to isolate x, I need to divide by 11 because remember, 11x is actually 11 times x. Okay? So 11x divided by 11, x equals 32 over 11. That's an improper fraction. Let's make it a mixed number. X equals 2 and 10 11ths. Now, you know the trick there is that you can take the 11, multiply it by 2, get 22, add 10 to it, gets you 32 over 11. So x equals 2 and 10 11ths, or 32 over 11. Well, let's see if that works when I go back, because you always want to check your work, kids. Always check your work, because if you don't, what's the point? Like, you're not going to learn anything if you're doing the wrong process. So let's go back and check our work. Erase this. I've got what I think is my answer. 11x minus 9. All right. so 11 times, let's use my new symbol, the little dot here, 32 over 11. Okay, and so 11 is the same as 11 over 1. So 11 times 32, 1 times 11. Let's see what we get here. 32 times 10 is 320. 32 times 1 is 32. Add them together. I get 352 over 11. Get my eraser. So I have 352 over 11 minus 9 equals 23. Add the 9. Now I have 352 over 11 equals 32. Okay, and let's see what happens if I divide 352 by 11. I have no idea whether this is going to work or not, folks, but it goes in 3 times. That is 33. Subtract that, I get 2, bring down the 2, 11 goes into 22 twice. Yes, 352 divided by 11 is in fact 32, and 32 does equal 32. Now, here's a little helpful extra tip. When you're multiplying fractions like this, you can make your life a lot easier by canceling out a numerator and denominator over here. Cross-multiplying is a little extra trick. Because if you know you're going to multiply by 11 over here, and you're going to multiply by 11 over here, why not just cancel that out and multiply by 1 each? Would have given you 32 over 1. I wouldn't have had to do 352 divided by 11. But the reason I did that is to show you that you can do it. And that's what it was, 352 over 11 minus the 9. Okay, you add the 9 to both sides. 352 over 11 equals 32. And that, in fact, works. So you just have to be patient when you're doing your algebra. Let's do one more problem, and then I'll give you guys some follow-ups. And the follow-ups are going to be just as random because I really want you 6th graders to dig in and get used to having to deal with fractions that aren't necessarily very comfortable to work with. It gets messy, and that's okay, as long as you're following the process. Remember, algebra is the reunion of broken parts. You have to socially isolate x and reunite it with what it's supposed to be so you can have equality. Okay, so here we go. Let's do 3 plus 15x equals 35. Who knows? All right, there we have it. Well, even though I've got the 3 on this side, this is adding a 3, so I'm going to subtract a 3 here. Subtract a 3 here, that cancels out. That means 15x equals 32. Remember, 15x is the same as 15 times x. So, gotta divide that by 15. X equals 32 over 15. If I make it a mixed number, x will equal 2 and 2/15. Remember the trick. Multiply the denominator by the whole number. That gets you 30. Add 2, that gets you 32. So x equals 2 and 2/15 or 32/15. Gonna write that over here. And then I'm going to erase them because I'm going to go back here and I'm going to try to solve this problem. Okay. 3 plus 15x equals 35. Let's subtract 3. 32 equals 15 times 32 over 15, and I can do 15 over 1 there. Looks like I've got something here. I will go ahead and do it the old school way first. I could just cross out the 15s and 32 equals 32, but just to show you that it actually works, let's do 32 times 15. Double check, 10, 15, 16 plus 160 plus 32. All right, so we get 480 over 15 equals 32. Let's do the division. Always divide the numerator by the denominator. This is your dividend, this is your divisor, and this will be your quotient. It goes in 3 times 48. Nope, 45, sorry. Subtract that. 48 minus 45 is 3. Bring down the 0. 15 goes into 30. Twice. Yep, 480 over 15 does boil down to 32, and 32 does equal 32. Everybody is happy because we have reunited x with what it needs to be. All right. But again, I could have just done this. If you're going to multiply this side, and you're going to multiply this side by the same thing, just cancel them out. You would have gotten 32 over 1 equals 32, and 32 divided by 1 is, in fact, 32. All right. Let me write some follow-up problems for you guys to do. I can't promise they're going to be perfect, but I can say that they are going to be fun. 5x plus 5 equals 30. That one's an easy one. Second one, 17x minus 31 equals 120. I have no idea how that's going to turn out. I'm going to have to solve that one. Third one is going to be, let's stick with the same theme here. Actually, no. X divided by 120 plus 3 equals 275. I have no idea how that's going to work out. I better take a picture of that with my phone so that I make sure I solve these problems. Those are 3 follow-up questions that I would like you to post in the classroom. I would say we're probably going to post those with Google Docs. You can show your work there, or you could do it on a piece of paper and then take a picture and upload that to the Google Classroom as well to turn in for this assignment. But practicing algebra, basic algebra, as we're working on slopes and everything, is really going to help you understand why solving for x and solving for different variables is very important. I learned a lot from preparing this presentation. I learned that algebra, the reunion of both broken parts, is attributed to Muhammad al-Khwarizmi, and he lived from 780 to 850 CE during the golden age of Islam. And I love the idea that it's a reunion of broken parts. I think that's great. And I really like the idea of isolating x. You got to get x. You got to balance that equation so you find out what exactly x is and reunite it with the number that it needs to be. So that has been a basic algebra presentation for you 6th graders with your 3 follow-up questions to do. Thank you for listening. Have a great day.